Hello everyone, this is our final project, the portable distance sensor created by Crist and Cocchi. So the requirements for our design was that the embedded system will interface the IR sensor using the PMOD AD1. An SPI core will be used to input the IR sensor data. The resulting distance in centimeters will be displayed on the PMOD CLP. And another SPI core will be used to output a buzzer tone through the PMOD DA2 to the buzzer to be heard by the user in the car.
And here's our system block diagram. We decided to use a battery pack, 3 AA batteries, to power our distance sensor. We had it coming in through the ADC through an SPI core. And then here we have our outputs to the LCD, and then also through the SPI and DAC to the buzzer. Our design overview for the hardware, we use the digital PMOD CLP, the LCD screen, the AD1 and DA2 also. And then we used a Sharp IR distance sensor. It said it had a range of 10 to 80 centimeters, but we were able to get it from around 7 to, it worked up to 200 centimeters with just not as good accuracy. And then also electric piezo buzzer. For the software, we used some code from previous labs, the LCD, AD1, and DA2 code. They're all able to just use that again. A lookup table was used to store all the values that we brought in. That was the easiest way for us to do it. And then the square wave to power the buzzer.
For our testing, we set up the IR sensor on the Nexus box, so it would be perfectly at a 90-degree angle. And then we took a piece of paper and we measured out values, which you can see. That's a 10 centimeter value right there. And there's 1 centimeter after every one of those. So and then on the display right now is the 81 value. So John and I, we took a Excel spreadsheet and you read off that value, move it, keep going until we got all the values up to 80. And then we decided to keep going past 80. We discovered that past 80 we could only go about 10 centimeter increments. So past 80 we went in 10 centimeter increments and got values. And then that's just a picture of our setup. We used the tapes of these together just to make it so it was a bigger obstacle. And then for our demo, we actually mounted it on John's truck. And so you can see you kind of have to see the sensors right here on the very back of it. And then we wired that up through the tailgate. You can kind of see the breadboard sticking out right there. And then we put the laptop and the Nexus board and all that in the back of the truck and had it all hooked up. And we took the buzzer and we wired that with that long wire all the way up to the front of the cab. So all the way up there. And then we put that right behind John's headrest so you can hear the sound beeping. And then he stopped at 9 centimeters to the object, which we actually have a demo of, that we'll show after we do our demo over there.
So the idea is just gather around their bench.
Off displaying like probably the farthest to the object that it can possibly get, and then as you put an object within range.
Oh wait, that would be way better.
Okay, now that it's powered, it'll tell you exactly how far away it is, and as you move it closer, you can see that it decrements on the LCD, and if you can hear the tone, which is right over here, the tone changes as you get closer to the object until you get within 10 centimeters, and it tells you to stop. And that's how we used it to create a backup sensor.
I'll show the video on the laptop. That's cool. Quicker. And then we hooked up to John's truck and had him in the truck back up to it. Put a piece of board right there behind the truck. So because we didn't want to do it against the wall, so he didn't crash.
So John's in the car, and all he's listening to right now is the buzzer as he's backing up. So yeah,
And
that's our project.
that's our
right there.
You
project.
hear the buzzer then?
Yeah,
Yeah.
because we had the
Especially
buzzer
at the
going
windows up.
from the back all the way to the front.